17. Let's first define what is decrease plus and decrease. So decrease plus is a GK stable WR invert P subalgebra defined to be increase invert P. So in particular, this is contained in B-drum plus. Because B-drum plus, recall this is inverse limit. WR invert P, and then kernel power, right? And we have mentioned that increase is injective into B-drum plus. Another way is to say that element of increase could be written as power series with divided power and coefficients in WR. Those divided powers the lies in WR invert P. And this completion for this p-adic topology guarantee that the elements of increases always converges in B-drum plus. Then the crystalline period ring decrease is defined to be decrease plus invert T. This is the same as a increase invert P, then invert T, but as we have done this exercise, that T to the power P minus 1 is lies in the ideal of increase generated by P. So actually, when we invert T, you also invert P. And so this is actually the same as increase invert T. Everything is then contained in B-drum plus invert T, which is in B-drum. Then a theorem without proof is that the natural GK equivalent map decrease tensor over K0. So it is in particular K0 algebra. K0 is W small k invert P over K. This tensor injects into B-drum. So the proof of this is complicated. You could look at reference in Fontaine's paper, 1982. And a relatively easy thing is that if we give subspace filtration over decreased tensor over K0 is K, then the graded piece, which means the graded algebra associated with this, would be isomorphic to the graded algebra of B-drum. We know what is the structure of the graded algebra for B-drum, and that graded algebra is what I described before, which is BHT. Each graded component is claimed to be dimension 1, so we can left this as a sub-exercise. So now let's add more remarks. We want to detect how the Frobenius is acting on equals 0. So let's just do this proof as a lemma. The WR subalgebra equals 0 contain the WR 1 over P is phi stable proof. So over WR, Frobenius is given by component wisely read into P's power. This is because R is characteristic P. Now for any element with ring, its Frobenius of B is congruent to B to the power P modulo P. Because modulo P, this will become 0 to the power P modulo P wait, what am I saying? Let me think. So I'm just saying that modulo P, this is our B mapped to B bar and B to the power P with Frobenius of B mapped to Frobenius B bar, B to the power B mapped to B to B bar. I'm claiming that they are the same there because this modulo P is yeah, because both just take this general form. So this is Frobenius of B, and so modulo P just gives you this, while P to the power B, B to the power P corresponds to there is 0 to the power P, and then whatever there modulo P gives you also this. I'm assuming this is B. Also, this is strange. Should we call it A? Therefore, Frobenius of C equals C to the power P plus something divisible by P. Let's call it eta. And then this could be written as similar argument P minus 1 factorial then gamma P of C times P of eta. So let's move this P outside with some eta in W of R. And Frobenius of C to the power m is then P to the power n P minus 1 factorial gamma to the big C plus eta outside power n. Hence P to the power m over m factorial is inside ZP. For all n bigger or equal than 1. We have that Frobenius gamma m c equals so this is c to the power m factorial just a similar thing, just finally divided by m factorial. So this is, we just copy it, eta plus b minus 1, the similar thing as here, just finally times p to the power m divided by m factorial. So this shows that this is again increased 0. And so we have proved that this divided power is again stable under Frobenius. So increased 0 is stable under Frobenius. So here we have divided power. And this is in ZP, so nothing to worry, okay? Put as a sub exercise. This p to the power m divided by m factorial is inside ZP for any n bigger or equal to 1. Remark. The endomorphism of increased 0 induced by Frobenius on this WR invert P extends uniquely to a continuous endomorphism. Of the p-adic completion. Increase. Recall that increase is the p-adic completion of increase 0. And hence this extends to endomorphism. Frobenius on decrease plus, which is by definition increase invert P. I mean, you just have to define what is Frobenius over P, then it's okay. As is just defined to be trivial action. And this extends to Frobenius on its subring WR 1 over P, because WR is containing increase, so this is containing increase in 1 over P. Exercise 2. Do the computation, show that phi t is P times T, where we call T is log of attachment relief to epsilon as before. Proof. To prove, so recall that we have proved this T is containing increase. Right, we prove this. How do we prove that? We show that definition of log epsilon, which is the summation of power series of epsilon minus to the power n divided by over n. In priori, this is in beta plus, but actually it's in increase. By we checking because it converge for the p-adic topology of increase. Right, we just recall we rewrite it as divided power times some element, and then you see that element p-adically tends to 0. We can use p-adic continuity to compute. Because T could consider here, which is p-adically completed. And there is embedding increase into beta plus, so we can use p-adic continuity. So phi t is summation from 1 to plus infinity minus 1 to the power n plus 1 Frobenius epsilon minus 1 to the power n divided by n. And then just compute it. Frobenius is acting component-wisely, and so it's acting on epsilon in the first position and then 0 on the other position. And so this is just the attachment relief of Frobenius of epsilon. but acting on any element by definition is reason to the p's power, in particular on epsilon. And recall that the Frobenius on increase extends the Frobenius on WR. So phi of t by that formula it's log epsilon of p, which is log epsilon of p with log epsilon of p, yeah, because it's multiplicative. Good. And this is p log of epsilon, right? Remark: we can extend this Frobenius to decrease just by define this to be 1 over pt, and then we have Frobenius over decrease, which is defined to be, recall, increase over t. Second remark: let's mention the theorem of Fontaine, the Frobenius endomorphism. Frobenius from increase to increase is injective. In particular, the induced Frobenius decrease is injective. Third remark: we gave decrease the subspace filtration by decrease inject embeds into K tensor K0 decrease, and then into beta run. Okay. Okay, so I'm sorry, so which means we should not describe the filtration trivially. We don't know what is filtration before we introduce this. So the filtration of this group after you embed it into beta run, then you have the filtration induced from the run. For an integer, we define field I of p decrease to be decrease intersection with field I beta run. Those beta ram is given by beta ram plus and then times t power, right? One should be aware that the Frobenius operator on decrease does not preserve the subspace filtration. Because kernel theta is not preserved, not stable under Frobenius, right? We have showed this before. More precisely, we have so C is killed by theta, while 5C is not. Not killed by theta. Exactly as what we proved. Finally, see this is minus p plus p equals 0, or this become minus p to the power p plus p, so not equal to 0. And so this C, because it comes from beta run, no, on beta run we don't have a stable filtration. A Frobenius stable filtration, neither here. So the filtration is not changed even after we have introduced decrease.